Hello and welcome to yet another interesting video from Anritsu. I'm Navneet Kataria and I'm the Product Marketing Manager for Anritsu Benchtop product line. In this video, we are going to show you a very special case for application requiring high input power to drive active amplifiers or other active devices working in the D or G band. As you can see here, we have a combination of VDI mmWave modules working in collaboration with Anritsu Broadband mmWave modules. These modules on the right can actually cover right from 70 kHz to 220 GHz in a single sweep. On the left hand side, you are seeing a VDI mmWave module working in the D band. There are a lot of 6G and beyond 5G applications working right now in the D band. These active devices need higher input power to push the amplifiers into the saturation or the nonlinear region and to check the gain, IMD, harmonics and other measurements. If you have a high input power requirement, it is recommended to use VDI mmWave modules. Now, the challenge with a lot of customers has been that for, say, characterizing devices in E band, W band, D band and G band, you need to have two of these VDI mmWave modules on both sides to make waveguide banded measurements, which means you need to have 8 of these VDI mmWave modules covering for E band, W band, D band and G band. That is a very costly solution, and there are a lot of challenges for doing calibration, repeatability, calibration accuracy and measurement stability. Imagine if you have to do 8 measurements to characterize your devices right away starting from E band to G band. In that case, first you will have to have 2 VDI mmWave modules, do a waveguide calibration, make a measurement, remove those 2 bands, put in the new another mmWave VDI test set and the modules and do different measurements. However, since this combination can now work, what you could have is you could have one side VDI having E band module, D band module and G band module. However, on the receiver side, since this guy covers from 70 kHz to 220 GHz, you need not change the setup at all, which means now you only need 4 mmWave modules, 1, 2, 3, and this one is a 4th one which covers right from 70 kHz to 220 GHz. This is a very interesting solution. For making this VDI and Anritsu mmWave combination to work, all you need is a 70 GHz vector network analyzer called VectorStar from Anritsu, and then a mmWave test set to support the frequency ranges going right up to 220 GHz. As we all know, for making correct active device measurements, you need to make sure that the input power delivered to the amplifiers or the active devices needs to be calibrated, which basically means you have to make sure that the output power coming out from the VDI mmWave module should be accurate. For doing that, we do a power calibration at this reference plane. How do we do that? Anritsu has developed the drivers for the Erickson VDI power sensor, which you can see here, and the VDI Erickson PM5 power meters. With this combination, all you have to do is attach this power sensor to this VDI waveguide interface, control the power from the VectorStar to make sure that the power levels are accurate, and note the reading at that PM5 power meter. We just discussed how to do a power calibration with the VDI mmWave module and the VDI PM5 Erickson power meter. Let's talk a little bit more about Anritsu mmWave module, which goes from 70 kHz to 220 GHz. We all know that this mmWave module has a 0.6 mm connector. However, we are all talking about waveguide measurements here. In that case, we need to attach a 0.6 millimeter to a particular or specific waveguide adapter. Anritsu has a full line of 0.6 2 waveguide adapters. I will show you a zoom feature of this. This side you can see a 0.6 millimeter coaxial, and on this side we have a waveguide interface here. For making proper connections between the Anritsu millimeter wave module and the VDI millimeter wave module, you need to attach this waveguide adapter to Anritsu millimeter wave module, and bingo, you are good to go. Make your waveguide measurements. After connecting the coaxial to waveguide adapter to the millimeter wave module, you are actually ready to make your on-wafer or waveguide measurements. As we all know, in the D band, the amplifiers can have really high output power. There is always a chance that the output of the amplifier may compress this receiver or our millimeter wave module. In that case, it is always advised to use an attenuator which is waveguide in nature. So what you could do is you could connect this waveguide between the two modules or at the end of your test device, and then you can always de-embed this attenuator from your final measurements.